What we're looking for here in number 1 is to find the numbers for which this expression right here is undefined. Now, when we do these, we're just looking for the values of, say, y in this case, that is going to make this expression non-computable. And all we have to do is look for the denominator, right? We can have 0 in the numerator, but not 0 in the denominator. So what we're going to look at here, we're going to ask ourselves this question here: what is going to make y minus 4 equal to 0? So we just have a little equation to solve there, and that's going to be y equals 4. So we're claiming now that 4 makes this expression undefined. And you can see that it's true, because if you do put in 4, what do you get? Negative 20 times 4 over 4 minus 4, you get negative 80 over 0, which is undefined. Now here in problem number 2, we want to find the values of x that will make this expression undefined. And again, all we have to do is look at the denominator to see what's going to make it 0. Right? The numerator has no effect. Numerators can be 0. We don't want denominators to be 0. So we're going to say what is going to give x minus 8 to be 0. So again, a little equation to solve. X equals 8. So the value of the variable that makes number 2 undefined is 8. So in our very first problem, we want to know this. When x is equal to negative 2, what would be the value of 4x minus 5x squared all over 3x? So let's put in negative 2 for all the x's. We're going to put a negative 2 here, a negative 2 here, and a negative 2 here. So let's do it. We'll get 4, put a negative 2 in for that x, minus 5, put a negative 2 in for that x, we'll square that, over 3, and put a negative 2 in for that x. So let's see what happens. 4 times negative 2, well, that's going to be a negative 8, minus 5. Now remember, do powers before the multiplication. So negative 2 squared, that's going to give us 4, all over negative 6. We'll get negative 8 minus 20 all over negative 6. How about negative 28 over negative 6? And a negative over a negative, right, that's going to be a positive, and we can reduce this. 2 divides each one of those. So how about if we write 14 over 3? In this next group of problems, 2 through 7, what we're going to try to do is find the values of the variable, y in this case, that make this expression undefined. Like that means it's not computable. You know, back over here in number 1, negative 2, that is a value that makes this expression defined because we can compute with it. But what we want to know is what values of y will make this expression undefined. When we do these problems, really all we need to do is look at the denominator. Numerators can be 0, but we just don't want denominators to be 0 because that'll make our expression not computable. So what we're going to do here is look at that denominator, y minus 4, and ask what's going to make it equal to 0. So we'll just set the denominator equal to 0, and then we'll solve a little equation here, y equals 4. So here's the question. The question says this: find all numbers for which the rational expression is undefined. So we got y equals 4, but to answer the question specifically, we'll just say 4. In number 2, what values of x will make this expression undefined? Well, we don't have to worry about the numerator, right? Numerators can be 0. We just don't want the denominator to be 0. So let's set that denominator equal to 0 and solve. So another simple little equation again, we'll get 8. But remember what the question says. It says find all numbers for which the expression is undefined. We solved our equation. We got 8. So the numbers, though, are just 8. Now look at this expression here in number 3. We've got a numerator, x minus 7, which is not anything we have to worry about, right, because numerators can be 0. But now we have a quadratic in the denominator. What's going to make this equal to 0? So we're going to ask x squared minus 2x minus 48 equals 0. And what values of x produce that? Well, this is a quadratic equation. We know how to solve these. Something equals 0. So let's factor x and x. And I think what we're going to get here is 6 and 8 looks like a good combination. How about minus 8 and plus 6? from which we are going to get, getting a little low there, we're going to get x is 8 and negative 6. So the numbers that we're looking for are not x equals, but just 8 and negative 6. Either one of these two numbers are going to give us 0 here in the denominator and make this expression undefined. Oh no, you know, I just wrote number 4, and then I realized back over here I've got two number 2's. Let's switch this. This one here is really number 3. Good grief. This one here is number 4. And now what we're going to look at here, I think I can fix this. This is going to be number 5. Okay. So number 5. Number 5 is this expression, x squared minus 25 over 6. And now, just look at, right, all we have to do is look at the denominator, and we're going to ask, what's going to make this denominator 0? Well, 6 is 6. It's never 0. So there are no numbers that are going to make this one equal to 0. So we're just going to say, find all numbers for which the expression is undefined. There are none. Right? There's no number that's going to make that denominator 0. The denominator is always 6. And speaking of 6, let's go to problem number 6, and I think I got the numbering right this time. It's x squared minus 4 over x squared plus 9, and then we're going to ask what's going to make this denominator 0. So what we're looking at is this equation here, x squared plus 9 equals 0, and we know this does not factor, right? It doesn't factor because we got a plus here. This is the sum of two squares, and it doesn't factor. So we're going to write none here. This is never going to be 0. And in fact, you can get that idea here, right? That pick any number you can think of. If you square it, it's going to be 0 or positive. So this number here is at least 0 or positive. And you add 9 to it, it's just going to make it bigger. It's never going to bring it back to 0. So the answer here, as in the last problem, is none. This expression here is computable for every number you can think of. Let's do one more of this type here. What we want to know is what's going to make this expression undefined. And again, we don't have to worry about the numerator. That can be 0. But what's going to make this denominator 0? So let's set it equal to 0. X squared plus 8x plus 16 is 0. And we'll factor this, if we can. How about x and x? Now 16 and 1 is not going to work. 8 and 2, not. How about 4 and 4? 4 and 4, 16 is positive, so they're both going to have that middle plus sign. So what we're going to get out of here is x equals negative 4 twice, but we just need to write it once. So what values of x are going to make this undefined? Just one of them, and that's going to be negative 4.